We are working on operations with rational expressions, solving rational equations, and solving radical equations today. This is our final review. So with simplifying rational expressions, we want to make sure we factor the numerator and denominator completely. We're going to divide by a form of 1. These forms of 1 will be something over itself, whether it's x plus 2 over x plus 2, x minus 3 over x minus 3. Those simplify to 1. You can leave both numerator and denominator in factored form. You don't have to multiply them back out or anything like that. For adding rational expressions, we want to factor the denominators. Then we're going to want to go ahead and find the LCM of the denominators, which we'll also refer to as the LCD. We're going to multiply each rational expression by a form of 1 so that the rational expressions have common denominators. Then we're going to add the numerators and keep that common denominator. So we write it all over the common denominator. Then we want to simplify if possible, and again, leave it in factored form. To subtract rational expressions, we want to make sure we distribute the negative to all terms in the numerator, so just the numerator. That is directly after the subtraction. And then we're just going to go ahead and follow our rules of addition. For multiplying rational expressions, we want to factor all the numerators and all of the denominators. Then we're going to go ahead and divide out forms of 1 from any numerator and any denominator. So if it's in one numerator, one denominator, we can divide those out. And we call this cross-simplifying or cross-reducing. I think you've used that term too. Dividing rational expressions, super similar to multiplying. We're going to go ahead and factor all of our numerators and all the denominators. Then we're going to multiply the first rational expression, so the first one we have, by the reciprocal of the second rational expression. So we talked about this as keep, change, flip, right? We can't divide when we have fractions. We have to multiply by the reciprocal. Then again, we're just going to divide out forms of 1 like we did that in the multiplying, and again, it's still called cross-simplifying. Again, we can leave that numerator and denominator alone. Last thing we went over with these rational expressions was simplifying complex fractions. We want to factor all the denominators of the smaller fractions. So this is when we have fractions within a fraction. Then we're going to multiply by a form of 1. This form of 1 will be the LCM of the denominators over itself. So again, we're going to do plenty of examples of these. Then we want to simplify if possible. Again, leave everything in factored form. Remember that denominators cannot equal 0. So we need to state all real number restrictions on the variables. So our first example says simplify or do the indicated operation and then simplify. We want to state all the restrictions on the variable. So we're going to go ahead and look at A first. So I'm going to go ahead and factor that numerator. So we have x squared plus 7x minus 8. This is going to factor into x plus 8 times x minus 1. Over in our denominator, I see that I can factor out a 4, greatest common factor of 4 first. So I have 4 times x squared minus 2x plus 1. I see that I can factor that trinomial again. So I'm going to keep my numerator of x plus 8 times x minus 1. I'll have 4, and this x squared minus 2x plus 1 just factors into x minus 1 squared. So now that I have it all simplified, all factored. We're going to go ahead and simplify. So I see that I can simplify an x minus 1 and an x minus 1. So we're just changing this to an exponent of 1 instead of 2. So our final answer is just x minus 8 over 4 times x minus 1. Our restriction, we have to just look at our denominator. So looking at this denominator here is going to give me x cannot equal 1. Okay, B. We have y squared minus 2y minus 35 over 2y to the third minus 3y squared times, so we're now multiplying instead of just simplifying, 4y to the third minus 9y over 7y minus 49. So I'm going to go ahead and factor my numerator. So this factors into y minus 7 times y plus 5 over, we have we can factor out a y squared. We're left with 2y minus 3 times, I have a y that I can factor out here. I'm left with 4y squared minus 9 over 7 times y minus 7. We can factor out that 7. So I see right here, we can factor the difference of squares again. So I'm just going to copy everything down. So I have y minus 7 times y plus 5 over y squared times 2y minus 3 times y. 4y squared minus 9 is the difference of squares, so it factors into 2y plus 3 times 2y minus 3. We keep this over 7 times y minus 7. Now I'm going to go ahead and simplify. So I see a y minus 7 in my numerator, y minus 7 in my denominator. I see a 2y minus 3 in my denominator, 2y minus 3 in my numerator. Don't forget about those greatest common factors. So y simplifies with y squared. We can just simplify 1. So I'm left with, in my numerator, y plus 5 times 2y plus 3 over, I have y times 7 left, so we're going to write that as 7y. Now we need to talk about our restrictions. So we always look at the denominators before they're simplified. So y cannot equal, with that y squared gives us 0. Y can also not equal, with the 2y minus 3, it's not going to be able to equal 3 over 2. And with the y minus 7, that tells us y cannot equal 7. Okay. C, we have c to the third plus 8 over c squared minus 4 times c squared minus 4c plus 4 over c squared minus 2c plus 4. So I'm going to go ahead and factor c to the third plus 8. That is just our sum of cubes. So this factors into c plus 2 times c squared minus 2c plus 4 over c squared minus 4 is just the difference of squares. So we have c plus 2 times c minus 2. C squared minus 4c plus 4 factors into c minus 2 squared, or c minus 2 times c minus 2. Does not matter how you want to write it. Over c squared minus 2c plus 4 cannot factor, so we leave it as that. Now we can go ahead and simplify. So I see a c plus 2 in my numerator, c plus 2 in my denominator. I see a c minus 2 to simplify. And I also see this whole trinomial c squared minus 2c plus 4. c squared minus 2c plus 4. So we are just left with c minus 2 for our simplified, where c cannot equal. I can't equal negative 2 here or positive 2 here, so we're just going to say plus or minus 2. We're not going to worry about the trinomial, the c squared minus 2c plus 4, because that doesn't give you like a nice clean number. D, now we are working with division. So I'm going to factor everything and make sure I also change it to multiplying by the reciprocal. So I have 25z squared minus 4. That's the difference of squares. So I have 5z plus 2 times 5z minus 2 over z squared minus 9 is another difference of squares. So that's going to be z plus 3 times z minus 3. I am going to change this division now to multiplication. I'm going to factor 3 minus z. I'm going to factor out a negative 1 as my greatest common factor, because I always want my variable to be positive if I can. So that's going to give me positive z minus 3 over 5z minus 2. I cannot do anything to, so we leave it as 5z minus 2. Now I'm going to go ahead and simplify. So I see a 5z minus 2 in my numerator, 5z minus 2 in my denominator. I see a z minus 3 in my numerator, and a z minus 3 in my denominator. So we're going to simplify this to negative 1 times 5z plus 2. So we can just leave it that way. Over just z plus 3. And now we need to state our restrictions. Z cannot equal. So I have negative 3 and positive 3 here. So I'll say plus or minus 3. I need to check my original denominator of 3 minus z. That would also give me 3. So I've already written that one down. And then we have 5z minus 2. So z cannot equal 2 over 5. Moving on to E, we have 2 over x squared minus 4 minus x plus 3 over x squared minus 3x plus 2. Before I do anything, I'm going to just go ahead and change this to addition and change my signs to negative in my numerator only. So those are the only ones we change. Now I'm going to go through and factor my denominators. So I have x squared minus 4, so that's going to factor into x plus 2 times x minus 2. I have x squared minus 3x plus 2, so that's going to factor into x minus 2 times x minus 1. So now that those are factored, we now need to figure out what our least common multiple or least common denominator is. That way we can figure out what we have to multiply by. So our LCD is going to be x plus 2 times x minus 2 times x minus 1. So this is where we need to look at our first fraction, and what are we missing from that denominator? We're missing an x minus 1. So we're going to go ahead and multiply our numerator and denominator, both of them, by x minus 1 over x minus 1. On the second fraction, what are we missing from our denominator? That's x plus 2. So I'm going to multiply our numerator and denominator by x plus 2 over x plus 2. So now I'm going to rewrite it all over one denominator, rewrite it with our multiplication. So I have 2 times x minus 1 plus negative x minus 3 times x plus 2 all over our LCD of x plus 2 times x minus 2 times x minus 1. Now I'm just going to go ahead and simplify this. So I have 2x minus 2 minus negative x times x is negative x squared, minus 2x, minus 3x, minus 6. So make sure we FOIL that. All over our LCD of x plus 2 times x minus 2 times x minus 1. Now I'm just going to go ahead and combine like terms in my numerator. So I'm left with negative x squared minus 3x minus 8 all over x plus 2 times x minus 2 times x minus 1. I cannot factor that numerator, so we are done. And then we just have to put in our restrictions. So x cannot equal plus or minus 2, or x cannot equal 1. Okay. F, we have y minus 9 over y squared minus 16 plus negative 1 minus y over 16 minus y squared. So I see if I just go ahead and multiply this fraction by negative 1 over negative 1, I will end up with y squared minus 16. So we will have the same denominators. So I'm going to go ahead and do that to start. So I have y minus 9 over y squared minus 16 plus, make sure I distribute that negative 1 to everything in my numerator and everything in my denominator, right? So I get positive 1 plus y, so I'm just going to write that as y plus 1 over, this gives me y squared minus 16. Now I'm going to go ahead and write this as one fraction. So I have 2y minus 8 over our y squared minus 16. Now I can factor my numerator and factor my denominator, so I'm going to do that now. So I have 2y minus 4 over y plus 4 times y minus 4. Our y minus 4 simplify. So I'm just left with 2 over y plus 4. And my restrictions are y cannot equal plus or minus 4. Okay, let's look at this complex fraction. So we have 2 over a plus 2 over b over a squared minus b squared all over ab. So when we're looking for a least common denominator, we need to look at the denominator of a, the denominator of b, and the denominator of ab. So this tells me that I'm going to want to go ahead and use ab to multiply all these smaller fractions by. So I'm going to multiply this numerator by ab, and I'm multiplying this denominator also by ab. So that gives us the multiplying by a factor of 1, right? ab over ab. So if I multiply 2 over a times ab, that just gives me 2b. When I multiply 2 over b times ab, that just gives me 2a. And when I multiply my denominator by ab, my ab's just cancel. So I'm just left with a squared minus b squared. Now I see that I can factor these. So I'm going to factor this into 2 times. I'm just going to switch the order of this as a plus b. And I know a squared minus b squared factors into a plus b times a minus b. I see I can simplify my a plus b's. So I'm just left with my answer of 2 over a minus b. And you guys do not have to do restrictions when you're doing complex fractions. So this is our final answer, 2 over a minus b. Okay, let's look at b. This one looks a little bit more complicated, so I'm just going to start by rewriting everything with all of the factored denominators. So I'm not going to try to fit it in there. So I have 1 over x plus 1 times x minus 1 plus 5 over x squared minus 5x plus 4 factors into x minus 4 times x minus 1. This is all over 1 over, this gives me x plus 1 times x minus 1 plus 2 over x squared plus 3x plus 2 factors into x plus 2 times x plus 1. So now I need to look at all of my denominators here. I see I have an x plus 1, x minus 1, so that needs to be in our LCD. This x minus 4 needs to be in our LCD, and this x plus 2 needs to be in our LCD. So I'm multiplying my numerator and my denominator by x plus 1 times x minus 1 times x minus 4 times x plus 2. We're doing the same to the numerator and denominator. So x plus 1, x minus 1, x minus 4, x plus 2. So when I multiply 1 over x plus 1 times x minus 1 times my LCD here, the x plus 1, x minus 1 cancels, leaving me with just x minus 4 times x plus 2 plus 5 times whatever we're going to multiply. So if I have x minus 4, x minus 1 in my denominator, my x minus 1 cancels and my x minus 4's cancel, right? Leaving me with just x plus 1, x plus 2. So I'm going to have 5 times x plus 1 times x plus 2 over, I'm going to do the same thing with my denominator. 1 over x plus 1 times that LCD will just leave me with x minus 4 times x plus 2 plus 2 times x plus 2, x plus 1 will end up eliminating. So I'm left with x minus 1 times x minus 4. So reminder, you cannot simplify when you have addition. So we have x minus 1, x plus 4 here, and x minus 1, x plus 4 here, but they are being added to something else, so we cannot simplify them. So super important that we remember that. So now I'm just going to multiply everything out. So I have x squared minus 2x minus 8 when I FOIL that, plus 5 times, this FOILs out into x squared plus 3x plus 2. This is all going to be over, we have x squared minus 2x minus 8 plus 2 times x squared minus 5x plus 4. We're going to keep simplifying, so we get x squared minus 2x minus 8 plus 5x squared plus 15x plus 10 all over. We still have x squared minus 2x minus 8. Again, we cannot simplify anything yet because everything's being added and subtracted together. This gives me plus 2x squared minus 10x plus 8. Now we're just going to go ahead and simplify our numerator, simplify our denominator. So I'm just going to go through and add like terms. So I see x squared plus 5x squared gives me 6x squared. Negative 2x plus 15x gives me 13x. Negative 8 plus 10 gives me 2. Over x squared plus 2x squared gives me 3x squared. Negative 2x minus 10x gives me negative 12x. Negative 8 plus 8 simplifies out. I see that I can factor both our numerator and denominator. So this factors into 6x plus 1 times x plus 2 all over 3x times x minus 4. We can't simplify anything more, and we don't need any restrictions. So there is our final answer. So here we want to go ahead and solve rational equations. So our first step is going to be to factor all our denominators. Then we want to find the LCM of each of the denominators. Then we're going to go ahead and multiply both sides of the equation by the LCD. This is going to be so we can clear our fraction out. We don't want to have our fractions anymore. Then we're going to go ahead and just solve for the variable and check for the extraneous solutions. So if we remember, extraneous solutions is just where the denominator equals 0. There's those restricted values. So if you get a solution and when you substitute back in, your equation would equal, your denominator would equal 0, it is an extraneous solution. Okay. So example number 3a, we're just solving. So I only see one denominator that can be factored. So I'm going to go ahead and factor this x squared minus 4. So this factors into x plus 2 times x minus 2. So I see that the LCD is just going to be x plus 2 times x minus 2. So I'm going to go ahead and multiply both sides just by x plus 2 times x minus 2. So we can only clear fractions when we are solving an equation. So when there's an equal sign, so we have x plus 2 times x minus 2. And if you prefer to write it out that you're multiplying each fraction by your LCD, so you can kind of cross things out as you go, you can absolutely do that. Just make sure we're showing all of our work. So now our x minus 2's are gone from this one. I'm just left with x times x plus 2. Here in my second fraction, everything cancels, so I'm just left with plus x equals, over here my x plus 2's are gone, I get x plus 3 times x minus 2. Now I'm just going to go ahead and solve this equation. So I have x squared plus 2x plus x equals x squared plus x minus 6. I'm going to go ahead and subtract x squared and x over. I'm just left with 2x equals negative 6. We divide by 2, so x equals negative 3. And before I can say for certain that this is my solution, I need to check, is negative 3 an extraneous solution? And no, our excluded values would be 2 and negative 2. So x equals negative 3 is our solution. Let's go ahead and look at b. So I have 2 over x plus 4 plus 2x minus 1 over x squared plus 2x minus 8 equals 1 over x minus 2. So I can factor this second denominator into x plus 4 times x minus 2. And look at that. That's going to end up being our LCD. These are gone. So I'm going to go ahead and multiply both sides of the equation by our LCD. Again, that's the biggest difference with solving and just adding and subtracting is we are clearing our fractions here. Previously, we were adding two fractions together. So I'm multiplying by x plus 4 times x minus 2. And I'm multiplying by x plus 4 times x minus 2. So here my x plus 4's cancel. I'm left with 2 times x minus 2. Plus, here the whole thing cancels. I'm just left with 2x minus 1 equals, over here my x minus 2's are gone. I am left with x plus 4. So I'm going to go ahead and multiply these out. So I have 2x minus 4 plus 2x minus 1 equals x plus 4. Simplify down, 4x minus 5 equals x plus 4. we end up getting 3x equals 9. We divide by 3, so x equals 3. Again, we need to make sure that's not an extraneous solution. And when we look, 3 will not give us 0 in the denominator, so x equals 3 is our answer. Okay, let's go down to C. So I see that I can factor this x squared minus 4. That's going to factor into x plus 2 times x minus 2. So looking at our two denominators, our LCD is going to be x plus 2 times x minus 2. So we're multiplying both sides by x plus 2 times x minus 2. X plus 2 times x minus 2. So my denominators are gone. I'm left with x to the third plus 8 equals, here my x minus 2 simplify. I'm left with x squared minus 2x plus 4 times x plus 2. So I'm going to go ahead and multiply that out. X to the third plus 8 stays. I have x to the third plus 2x squared minus 2x squared minus 4x plus 4x plus 8. So I see these are going to cancel. These are going to cancel. I am left with x to the third plus 8 equals x to the third plus 8. If I subtract x to the third to both sides, I get 8 equals 8, which is a true answer. So our solution here is, since it's true, is going to be all real numbers. But we need to exclude anything that would be an extraneous solution or would give us or anything that would be an excluded value. So all real numbers except, what can our denominator equal? Well, it can equal 0, and having x equal -2 or x equal +2 would give us 0 in the denominator. So we say x can equal plus or minus 2. All right, last problem for this section. So D, we have 5 over x squared plus x minus 6 equals 2 over 1. So we need to make sure we remember that that's a 1. Minus, so I'm going to change this to a plus sign, -x +3 over x minus 2. So I'm going to go ahead and factor this denominator into x plus 3 times x minus 2. So that's going to be gone. Now I need to multiply both sides, including this 2 here, by our LCD, which is just going to be x plus 3 times x minus 2. So on this left side, I'm just going to be left with 5 equals 2 times, we have that x plus 3 times x minus 2, plus, on the last one, my x minus 2's would be gone. So I'm left with -x plus 3 times x plus 3. So now we're just going to multiply a bunch of this out and solve. So we have 5 equals 2 times x squared plus x minus 6. Now we have minus x squared minus 3x plus 3x plus 9. So this gives me 5 equals 2x squared plus 2x minus 12 minus x squared plus 9. Our -3x and +3x cancel out. Since I'm going to have an x squared term, I'm going to go ahead and try to get everything on one side and set it equal to 0. So, well, before I do that, I'll simplify more. So we have 5 equals x squared plus 2x minus 3. I'll subtract that 5 over. So we get x squared plus 2x minus 8 equals 0. I'm going to go ahead and factor this into x plus 4 times x minus 2 equals 0. So this tells me that x equals negative 4 or x equals 2. Again, let's go ahead and check to see if any of these would be extraneous solutions. And x equals 2 definitely would be because of the x minus 2 there. So that is not a solution. So our only solution is x equals negative 4. To solve radical equations, we want to first isolate one of the radicals on one side of the equation. It really doesn't matter which one we isolate. Then we want to raise each side to the power suggested by the index. So meaning if the index is 2, you raise it to the second power. If the index is 3, you raise it to the third power, and so on. Once you do that, and don't forget if you have more than one thing, if you have more than one term on one side of the radical, you need to FOIL when we raise each side to the second. So then we want to go ahead and isolate the remaining radical on one side of the equation. Raise each side to the power suggested by the index. Then we're going to solve, and we need to check all solutions to make sure that they work. So let's go ahead and take a look at our first example. So we have the square root of 3n plus 10 equals n plus 4. So I see that our radical is already isolated. It's already by itself on one side. My index is 2 that I don't see, so I'm going to raise both sides to the second power. On the left side, I'll be left with 3n plus 10. On the right side, I need to FOIL, so it's n squared plus 8n plus 16. From here, I'm just going to subtract 3n and subtract 10. Get everything to one side. So I'm left with n squared plus 5n plus 6 equals 0. I can factor this into n plus 2 times n plus 3 equals 0. So n will equal negative 2, or n will equal negative 3. So before we say that's our answer, let's go ahead and check those in our original. So remember to plug it into our absolute original, not with the squareds or anything like that. So I have the square root of 3 times negative 2 plus 10 should equal negative 2 plus 4. So square root of, so negative 6 plus 10 would give me the square root of 4. Negative 2 plus 4 is 2. Is the square root of 4 equal to 2? Yes. So we know we got the correct answer there. Now we'll go ahead and check our negative 3. So I have 3 times negative 3 plus 10 equals negative 3 plus 4. So I have negative 9 plus 10, which gives me the square root of 1. Is the square root of 1 equal to 1? Yes. So both negative 2 and negative 3 are solutions. Okay, B, I have the square root of m minus 1 plus 5 equals m minus 2. First thing I need to do is subtract this 5 to the other side to start, get that radical by itself, get it isolated on one side. So I'm left with the square root of m minus 1 equals m minus 7. Now I can go ahead and I'm going to raise both sides to the second power because our index is 2. On the left side, I'm left with m minus 1. On the right side, I need to make sure I use that binomial theorem, so m squared minus 14m plus 49. I subtract m and I add 1 to both sides. So I'm left with m squared minus 15m plus 50 equals 0. I can factor this into m minus 10 times m minus 5. So m is equal to 10, or m is equal to 5. So now let's go ahead and check our solutions here. So we'll first check the 10, see if that works. So I have the square root of 10 minus 1 plus 5 should give us 10 minus 2. So we have the square root of 9 plus 5 equals 8. Is 3 plus 5 equal to 8? It is, so we know we got that right. Now let's go ahead and check 5. So I have the square root of 5 minus 1 plus 5 is equal to 5 minus 2. So I have the square root of 4 plus 5 equals 3. Is 2 plus 5 equal to 3? No. So that means 5 is not a solution, so our only solution is m equals 10. C says the square root of x minus 9 minus the square root of x is equal to negative 1. So I want to isolate one of these radicals. So I'm going to go ahead and isolate this square root of x minus 9 first. So I'm going to have the square root of x minus 9. I'm adding the square root of x to both sides. So is equal to square root of x minus 1. Now I'm going to square both of these. When I square this right-hand side, I need to FOIL it out. So on the left, I'm just left with x minus 9. On the right, remember I'm multiplying by the square root of x minus 1. I'm left with x minus 2 radical x plus 1. Now that we've gotten here, I'm going to go ahead and isolate our next absolute value. So we're going to go ahead and isolate this absolute value, possibly with the 2 if we need to. That's not a big deal to square the 2. So I'm going to go ahead and subtract x from both sides and subtract 1 for both sides. So I am left with just negative 10 is equal to negative 2 square root of x. I divide by negative 2, so I end up with the square root of x is equal to 5. Now I'm going to go ahead and square both sides. So I'm left with x is equal to 25. So now let's go ahead and check to make sure that works. So I have the square root of 25 minus 9 minus the square root of 25 should give us negative 1. I have the square root of 16 minus 5 equals negative 1. Is 4 minus 5 equal to negative 1? It is. So x equals 25 is our solution. Okay, last problem, D. We have the square root of 2x minus 5 is equal to 1 minus square root of x minus 3. So our absolute value is already isolated. So we're going to go ahead and just start by raising both sides to the index of 2. I have 2x minus 5 on the left is equal to, remember we need to FOIL this, so it's saying we're multiplying by 1 minus the square root of x minus 3. So I get 1 minus 2 square root of x minus 3 plus x minus 3. Now I'm just going to move this stuff over. So I subtract x, I add 3, and I subtract 1. So I am left with x minus 3 equals negative 2 square root of x minus 3. So I'm going to go ahead now and square both sides because everything is not divisible by 2 or negative 2. So I'm going to go ahead and square both sides here. On the left, I need to FOIL into x squared minus 6x plus 9 is equal to, here, when I square negative 2 times negative 2 is 4. And I'm multiplying by the x minus 3. So I'm left with x squared minus 6x plus 9 equals 4x minus 12. I subtract 4x and add 12. I'm left with x squared minus 10x plus 21 is equal to 0. So then I have x minus 3 times x minus 7 is equal to 0. So x equals 3 or x equals 7. So we need to check those to make sure they both work. So I'm just going to check down here more. So I have the square root 2 times 3 minus 5 is equal to 1 minus the square root of 3 minus 3. So here I get 2 times 3 is 6 minus 5, so we have the square root of 1 is equal to 1 minus the square root of 0. 1 is equal to 1, so we know x equals 3 is a solution. Now we'll check our 7. So we have the square root of 2 times 7 minus 5 is equal to 1 minus the square root of 7 minus 3. So 2 times 7 is 14, minus 5 is 9, should be equal to 1 minus the square root of 4. So is 3 equal to 1 minus 2? It is not, so it's not one of our solutions. So our only solution is x equals 3.